right?
Maybe.
So let's see what we got. Phased arrays.
That's not practical. Talk about those. Depends how much money you have.
Effects of ground, folded dipoles, and other practical wire antennas. I guess they don't do impractical ones, right? I don't know. Some of these seem impractical. All right, so some of the beam or directional antennas, like Yagis, are nice, except they require something to hold them up, like a tower or a big mast, and particularly in lower frequencies. I mean, these are big antennas.
Leroy Cassie.
So one of the ways, if you can't afford towers, and also you have lack of real estate, you could do phased vertical arrays and get a directional vertical antenna. So it takes at least two. I think all the examples in here are using two.
Two or more quarter wave.
Right. So, and the radiation pattern you're going to get is determined by the way you feed it, the phase between the two antennas. So if you're feeding them both in phase, you'll get one pattern. If you feed one 180 degrees out from the other, you'll get a pattern. And if you feed one 90 degrees out, you get a different pattern. And also the spacing between them has an effect on it. So these are the confusing ones, and there's 3 questions on the test on these. You just have to keep them straight. It did show up on one of the tests the other night. So if you've got 2 quarter wave verticals that are a half a wavelength apart and you feed them 180 degrees out of phase, you get the figure 8, which are the 2 round lobes.
Long axis.
Broadside to the
Broadside.
right. If they're a quarter wavelength apart, as opposed to a half, and you feed it 90 degrees out of phase, you get the cardioid pattern, which is kind of like a heart shape, which is good for direction finding. If they're a half a wave apart and in phase, then you're going to get this figure 8 broadside to the axis. And I think there's example here. So if they're in phase, you get this pattern. If they're 180 degrees out, then you're just getting like 2 antennas.
And those are both a half wavelength apart, right?
Those are both half wavelength apart. Yeah. The difference is cardioid, where it's 90 degrees and quarter wave apart. And then this is showing if you got multiples, the effect. I assume these are quarter wave and you're feeding them each one 90 degrees. So you make it very directional, like an end fire. Of course, if you can space 4 antennas a quarter wave apart, I mean, that takes real estate. But these are the 3 that are on the exam. And actually, this one is showing half wave in there, but I think the pattern is still the same or very similar. In the test, it's quarter wave separation.
Yeah, the quarter wave goes back a little bit, probably quite a bit behind the top vertical antenna. It's a little bit more crunched forward.
Yeah, but it's the cardioid type pattern.
Yeah.
So what's the radiation pattern of 2 1/4 wavelength vertical antennas, a half a wavelength apart, 180 degrees out of phase?
Very long access.
Right.
On
It's just like two standalone antennas.
Very word question.
What's the radiation pattern of two quarter wave, space to quarter wave, fed 90 degrees out of phase? Cardioid. Now that one's easy to remember. It's the other two get confusing.
as it's in line of broadside.
So quarter wave, half wavelength apart in phase.
Omnidirectional.
Let's figure eight.
It's figure eight.
Broadside.
Figure eight. It's like doing a dipole.
Very direction.
If there was a quarter wavelength apart, it would be omnidirectional.
Right.
See, he knows. That's why he's here.
You only read three words, quarter wave vertical antenna.
Okay. It all depends on the phasing.
Yeah.
And they don't talk about if you fed it.
Out of phase, though.
If you fed it something other than 0 or 180, I mean, you're going to get a different pattern. In fact, well, you get the cardioid at 90, even at half wave part, right?
That handbook used to have a really nice section on that.
Steering.
Probably still does. Probably in the antenna book too.
It is.
Yeah. I have it there if anybody wants to check. Okay, so where you install the antenna and how high is going to affect its radiation pattern. So if you've got a vertically polarized antenna, which essentially means it's a vertical or a loop where you're feeding it on the side, so it's a vertical polarized, or it's a Yagi turned 90 degrees, so it's vertical. You're going to get a lower angle of radiation than if it's horizontal, which is one of the advantages of a vertical. You get a lower radiation pattern, so you get a longer hop, all things being equal. And of course, it works better over seawater than it does over rocky ground like Colorado or someplace. And I guess we're sort of in between. And this chart is showing, like the green one out here, you can see how much salt water affects the pattern. And that's a 40-meter monopole, which I guess is another name for vertical, right?
What?
That's a tall vertical, 40 meters. Well, no, it's
Well, it doesn't-
quarter wave,
yeah,
yeah. So it's
quarter wave.
still 30 feet.
So you're getting a wider radiation pattern over foreground than moderate ground?
You got back.
The best one is over water.
Yeah. That's a good question. The red is poor. And I can't. Yeah,
That's what that would
that's
say.
the blue one, right?
Yeah,
Moderate.
I would think that would be backwards.
Well, I didn't make the chart.
I guess it depends on your definition of poor, right?
Yeah. And it's hard to tell from this, but the one thing that changes is the elevation angle. So you can see on the saltwater, I mean, your peak is probably down here. It's really low. And then the other ones, you know, like this guy is probably there. So that's probably what, 30 degrees?
When they say salt water, does it have to be an appreciable depth, or can it be shallow salt water, or
Shallow.
Yeah.
line.
does it?
It's just it's the surface effect,
It's
I
just the
think.
surface effect of it.
So you could just flood your backyard with some salt water.
Well, that's what I was thinking. Flagpole with a moat around it.
Okay.
So, then you'd have to look at the near field effect and the far field effect, right?
Well, I don't know how you look. I mean, from what I understand, the near field is just meaningless because nobody
Well,
sees it.
I mean, if you have a little moat, it's gonna have some effect.
Right.
versus If you were.
But what you care about is how it affects the far field.
Right,
And
so I'm saying, if you had a little moat, how much effect really is there? Or is it the connectivity of a much larger area that affects you?
well, if you had a moat or pool, whatever, and you're in the middle of it, and it's as big as the radial pattern that you would have put down, it would be the same.
If you want to look at it, look at the readings on using ground radial. And what you'll find out is that if you have a bunch of short radials, 8th wavelength, 10th wavelength.
Yeah.
You can have a very, very effective radial system. Versus, going really long. Swing really long in a bunch is minimal. So I'd expect the same thing with your salt water. You don't need your salt water going out forever.
I mean, with the radials or your ground plane, it's diminishing returns. The bigger you make it, the less effective, less
gain.
additional effect.
Mhm.
Right? At a certain point, I mean, you're just wasting money. And that's, from what I read, that's how they determined this thing, the kind of myth about quarter wavelength radials. It was done by broadcast stations with their verticals, and they put out, because they could afford it, they put out radials that were 0.05 wavelength apart at the ends to get this pattern that looks like it was solid.
Yeah.
It turned out it's approximately a quarter wavelength. It had, it isn't really related to the wavelength per se.
That's why you'll see a lot of people take the aluminum screen or chicken wire.
Yeah.
And just put that out even under a dipole, not just around the vertical.
Or the
And
latest
ground
and
it.
greatest is Faraday cloth. You can go on
Yeah,
Amazon and buy a sheet of Faraday cloth and it's much easier to manage. But you just spread it out and sit your antenna tripod down on it and
yeah. If you're portable, if you're doing your yard, you can just staple the chicken wire down
And
not
let the
mow-
grass grow.
Yeah, and let the grass grow and bury it in.
Okay. So how is the far field elevation pattern of a vertically polarized antenna affected by being mounted over seawater versus soil?
Oh, increases.
Radiation increases delta.
I saw.
Tricky question. You got to read them carefully.
Doggy.
Okay, so where you put it
Did it, Ernie.
affects horizontal polarized antennas. So the takeoff lobe of a horizontally polarized, like a half-wave dipole, if you're putting it on other than flat ground, the ground will affect it. So if you put it on on a hill, the downside is going to have a lower takeoff angle than the high side. It seems reasonable. They're also saying if you've got a 3-element beam, of course, I think this applies to all the horizontals, but as you change its height, okay, it affects the main lobe or the takeoff angle. So the takeoff angle decreases the higher you put it. The downside is you get more of those on that diagram we saw, those other lobes popping up. When it's a half wavelength, you get a nice lobe. As you go above a half a wavelength, then you start getting multiple lobes. But the lowest one lowers. So, it's another trade-off because you're not getting all your power in that lowest lobe, but it is a lower takeoff angle.
Roughly half wavelength above ground is kind of like.
Yeah, they consider that the optimum.
You get a reasonable takeoff angle, but don't have those loss
Right.
and additional.
Yeah, all your power is going where you want it.
Of course, you got a 40-meter dipole and you can't put it up 33 feet, so it's lower, like 20, your takeoff angle goes up.
Right.
That's what happens. So
Right.
you're a little less, still not bad.
right.
So have you modeled tilting your vertical?
I haven't, but I can.
There you go.
So if I did it 45 degrees, I get the best of both worlds.
In one direction. In one direction.
More unidirectional to some degree with a higher takeoff angle.
Yeah, so do your in fire array and, slam them about, 5 or 10 degrees from the way you want. Get a super low takeoff.
I'll try that at QRP Saturday next time. Put my,
Yeah, okay.
put
Yeah,
my hand stick vertical on the slanted metal roof of the, let's see what happens.
yeah, there you go.
So how does the performance of a horizontally polarized antenna mounted on the side of a hill compare with the same antenna mounted on flat ground?
Alpha.
You want to read the question again, Michael?
The main load takeoff decrease. Yeah. In the down.
Okay, B.
You're getting a lower takeoff angle,
Right.
so it decreases.
Because the ground at the lower end is gonna affect it at a lower elevation.
Well, in effect, the antenna is higher, which makes the
It's
takeoff angle lower.
It's interaction with the
Right.
ground.
And it's going to do the opposite on the uphill side.
Yeah, raise it. Angle to some degree.
Of course, we don't have many hills to worry about here. So not an issue.
We got some up here.
Yeah, you're in that hilly country, aren't you? You
Yeah,
got trees too.
absolutely.
How does the radiation pattern of a horizontally polarized 3-element beam vary with increasing height?
Oh, increasing height, okay, so takeoff angle. Drop.
All right.
Baker.
Very good. Okay, so wire antennas, not my expertise, but we have a couple people who know all about them, right?
Yeah, maybe.
So we have long wire, which I think is defined as something more, at least one wavelength long.
In theory,
Yeah.
that's the fundamental.
Don't they also call those random wire? I think.
Yeah,
Random.
We have a folded dipole, which is a dipole with a parallel element connected at the ends. Raises the input impedance up to 300 ohms,
Somewhere around there.
which is why it's easy to make with 300 ohm twin lead.
Well,
and anything that's a loop is generally quieter as far as noise.
Okay, because it's a loop, right?
Yeah.
Off-center fed dipoles. And what's the other name for that?
If it's coax, it's off center fed dipole. If it's
Twin lead.
twin lead, then it's going to be a Wyndham.
Okay. The ZEP.
ZEP is generally twin lead fed. You can get variations of a ZEP. A J pole is a variation of a ZEP.
Yeah, because it's got a quarter wave feed
Matching.
line, matching
Yep.
line.
Yep.
Was it named after a guy named Zepp or what?
It's named after the Graf Zeppelin, and I think it was a guy named Zepp.
Okay.
They
Yeah, they use that kind of antenna under the,
under the Zeppelin.
yeah.
Is that a 5/8 wave all the time or not necessarily?
Not necessarily. The 5/8 wave is called an extended Zepp. And,
What's the regular quarter? Or half?
halfway.
Halfway.
Yeah.
And the G5 RV like that.
Yeah. And that's called a doublet because it's not a fundamental length of any
Yeah.
particular frequency.
Yeah, this one's for 80 meters, it's 102 feet long and has a 30.4 or 0.5, 0.6, 450 ohm twin link ladder line.
Yeah, standard doublet is 3/8 wavelength of the fundamental frequency, the low frequency. And then your feed line is an odd multiple in wavelengths, 8 wavelengths of the fundamental frequency. If it doesn't resonate correctly on a higher frequency, too high impedance, you trim it by an 8th wavelength of the higher frequency you have a problem with.
Okay. But it's essentially all bands, right?
Yeah, yeah.
Okay.
Yeah.
Okay, so a long wire is a long piece of wire. Normally they say it's at least a wavelength long, but one of the examples there is showing multiples of a half wavelength.
For a resonant long wire.
Yeah.
And on the other side, probably, you can have a long wire that isn't resonant.
Yeah, the random wire and long wire sometimes get confused. So random wire is a non-resonant length that is usually a wavelength long.
And their picture there for the long wire, where it's a wavelength long and it's got a quarter wave feed line going to it. And the resulting radiation pattern, which is kind of neat. It's got a big rear lobe, but it's fairly directional. And that is along the axis of the wire. So it's wherever your wire is pointing, right?
But you get longer than a wavelength.
And it says that you almost always need an antenna tuner.
Yeah.
So none of those will have 50 ohms.
A lot of times we're using the 9-to-1
9-to-1 on the random, that's not
plus random where it's not resonant.
And then
Not resonant frequency.
and then for in-bed half wave, it's typically 49-to-1. You'll see 56-to-1 and
Yeah.
64-to-1.
Okay, so what happens to the radiation pattern of an unterminated long wire antenna as the wire length is increased?
More gain, yeah, injection wire, more loads,
Right.
more gain.
So the longer it is, the more directional it is.
Yeah.
A folded dipole is a variation of a half wave dipole. Instead, you've got a parallel element that's also a half wavelength long, and they're connected at the ends. So it's in essence a very narrow loop that you're feeding in the center. And it raises the input impedance to about 300 ohms. So it's easy to match with 300 ohm twin lead. I guess they still sell that stuff, right?
Yes,
Yeah.
Yeah, but
you can also use the 450 ohm
yeah, well,
line.
Yeah, the window line. This is actually window line. Yes, little windows in it.
right,
Right.
at 450.
450.
But
Does the
again, don't
separation-
tie it real close, separate it a little further apart, you split it and go out. And that you pick up the 400.
Oh, more like a delta match.
Yeah, something like that.
Okay. What about the separation? Does that affect it?
Yeah,
So if it was farther apart, I did have a higher or not?
you'd probably have higher impedance. So why do you go the air dielectric? Because if you do like a 600 ohms,
No, I'm not talking about the feed line. I'm talking about the folded dipole separation.
I would imagine would affect it some.
Mhm.
Uh, there are some people that will actually take like 6 or 8 parallel conductors
Right.
And it actually makes it appear as one fat conductor.
Right.
But I think there comes a diminishing point as far as what happens with the impedance, but I'm not a theory guy.
I see that on the ships when they do long wire antennas on the mast up there, and they'll have like four or
Yeah,
they call it
broad-
caged or something, but yeah,
Yeah.
all in parallel.
Yeah, they'll broadband it.
Okay, so approximate impedance is 300 ohms. Twin lead is easy to make. I remember making those back when you used to get TV on the air or FM. So what is a folded dipole antenna?
Charlie.
Just a half wave dipole with a parallel element. What is the approximate feed point impedance at the center of the two-wire folded dipole antenna? Okay, an off-center fed dipole, sometimes called a Wyndham. Let's see. It's a Wyndham if it's fed with the balun and coax, right?
Oh, if it's fed with twin lead,
For some length, right?
yeah, of some length.
Then convert the.
Well, not according to the little picture that I found.
Yeah, well, if it's
So
off
do you-
center fed and fed with coax, then it's off center fed dipole.
Okay,
So you put the balun between the twin and,
With the Wyndham, you put the balun at in the twin lead. Okay, or you can just take the twin lead all the way to your tuner if you're, support twin lead on your tuner.
yeah, in theory, your twin lead is going to be the same impedance as the antenna.
right,
So you got to match, but then you got to convert before you get to the transmitter.
Yeah,
So where does it start radiating? though? It starts radiating as soon as it leaves your transmitter, right?
Well,
I mean, on coax, it's a little,
in coax, it's not supposed to,
it's not supposed to right there.
yeah,
because if it's perfectly shielded and balanced, then no signal gets out.
But if you have ladder line or something like that, doesn't that immediately?
It's got to
start
radiate.
Acting like a radiator?
yeah, the ladder line will act like a radiator, and then the classic Wyndham, you cut it to a certain length. And then go to a transformer.
Right.
But it still radiates
Yeah.
right there.
Just like on the G5 RV, that
Yeah.
ladder line or window line is part of the antenna.
I've seen both where like that. Ladder line or whatever.
And
Just
that's
say maybe
actually nice
an eighth
because
wavelength.
like an inverted L, you're getting low angle vertical and then not quite so low angle horizontal. So you're getting both vertical and horizontal.
It just seems like when using that type of antenna, your exposure is a lot higher than with coax.
Oh, yeah.
So that, you're supposed to calculate your antenna safety.
And by the way, they changed the rules on that. It came up in the new general. 1 milliwatt and above, you're supposed to do the.
1 milliwatt.
Yeah, so basically, any antenna, you got to do the radiation exposure
These are
calculation.
exempt pretty much.
Yeah, but it's easy to do. I mean, you just fill in
I've
4 or
done all
5.
that stuff and I got. Except at pretty high frequencies, running pretty significant power, it really is. But I mean, if you're, like even exclude 10 meters on 20, 40, 10.
Well, it's the 30 to
You got-
300 range is the worst.
Your 10 at 100 watts before it really does
Yeah.
anything.
6 meters is basically the worst.
When Byron's at QRP Saturday with his loop antenna and inadvertently fires up 100 watts, he might need not to do that too long, but other than that, you're fine.
Well, you could always do the aluminum foil hat. Because what you have to protect is your brain and your eyes.
I use the aluminum
Sure,
foil
that
jock
makes
strap
a lot of
too.
potential.
The what?
The aluminum foil jock strap.
So on all center fed though, there are off center fed ones
Right,
where you got a coax right up to the base.
Right.
And that's it.
and that's around 200 ohms, depending on where the offset is.
Yeah. Right.
When it's,
Yeah, 250,
what,
so-
like a third or quarter, normally is where they do them.
So
And
what's
that impedance is gonna vary depending on the position.
do they change the name of the off center fed if it doesn't have any kind of twin lead, or they do have twin lead, or is it just off?
There are 1,000,001 names, okay, for minor variations. Okay. So, and, the classics have been improved upon. And some of the, newer ones are, easier as far as getting more bands and with, less matching done, lower impedances.
Uh,
Rest of yours.
I guess the other important thing, which I think is a test question, like in this case, it's set up for 80 meters, so you're gonna be a good match and resonant on 40, 15, and 10. You don't get all the bands.
Doesn't get the even harmonics.
Get the warp bands, is it called? I don't call that anymore. but 17,
That
12?
shows up a lot. What does work mean?
World allocation radio.
Oh, okay.
Oh, see, he knows.
I don't, that's not a test question, but it does pop up a lot.
Like new bands in the 80s or something.
Okay, and normally with coax, you'd feed it with a 4-to-1 balance. Because it is a balanced antenna, and then you're feeding it with an unbalanced coax. As opposed to it being an
So, if it's balanced, but it's off center fed. Is that not an unbalanced antenna when it's not centered?
well, actually, it is somewhat unbalanced.
Yeah.
No, it is balanced. Because what that really means is the characteristic of the
Well, but
of the
you,
antenna conductor.
but you're gonna have common mode current.
Yeah, that's a whole nother issue.
If you didn't run it through the balun, you'd have common mode going down the coax,
Yeah.
because you're gonna have different current on one and the other, so they don't match, and they have to match inside the coax, so it's gotta go up or down the outside. I learned that.
The hard way.
No,
Oh, Oh,
unfortunately.
you learned that theory.
You can learn it the hard way by losing power and never being able to contact very many stations.
Okay, these are the radiation patterns that you see with an off-center fed. So at 80, and I'm assuming that is half wavelength high, because that's going to affect it. It doesn't say on this chart. But you can see how it varies as you're assuming it's a half wavelength at 80, then you're actually increasing the wavelength height for those other frequencies. So you're getting all these extra lobes coming out.
So that's what's the fact.
Normally, an off center fed doesn't work for the even like 80 to 40 or 40 to 20.
The,
It goes the odd one where they resonate.
135, yeah,
Yeah,
first. And then the dipole is even the straight dipole.
Well,
but
maybe DL1VU is wrong. I have no idea. I mean, I found this, it was a nice picture demonstrating it. How accurate it is, I don't know.
That may be the radiating pattern, but it may not resonate.
Okay, but we don't necessarily care, do we? If it's if it's radiating that pattern and we can contact somebody, isn't that the bottom line?
Well, I guess that's what you're really trying to do.
Well, the ultimate solution is put your matching unit at the feed point of the antenna And you don't care what happens to the impedance, you're gonna make it go out the wire anyway.
Because in practice, you're almost never operating at resonance
Yeah,
because there's only one point.
You're operating near residence, but long wire antennas, flagpole antennas for mass good nature, those aren't resonant, so we.
Fence antenna just eats the
Yeah,
wall.
we use non-resonant antennas all the time, so they don't have to.
Yeah, your rain gutter, is that resonant?
To rain it is.
yeah.
Okay, so which of the following is a type of off-center fed dipole antenna?
No, A would be one. See,
A would be one.
yeah.
What's orthogonically controlled frequency?
Frequency diversity, yeah. I have no idea what that is.
A is the only answer.
Okay, ZEPs,
There we go.
half wavelength. Now in these two pictures,
And,
see, we got a single ZEP, a single ZEP and a double ZEP, right? So it's one of those that's fed with twin lead. Now, in the one there on the bottom right, they're actually using that kind of quarter wave transformer. So the feed point is somewhere above the shorted end where you can match it to the 50 ohm feed. Because it's going to go from 0 where it's shorted all the way up to whatever the impedance is for that half wave off in fed, right? Which is going to be in a couple thousand.
and what does the J pole do?
The same
J-
thing.
The J pole just sticks it straight up instead
Right.
of out to the side.
And you feed it somewhere along that quarter wave section.
It's exact same thing. You just rotate that thing vertical instead of horizontal. It's a J pole.
Now, when we do it as the double, feeding it with 450 ohm ladder line,
Usually they'll just use.
just
that.
use, they're just showing a ballon there.
And you can extend that out, the Ringo Ranger. So if you take one that's basically a J pole, you can stack it by adding, quarter wave turnarounds. Okay, the quarter wave section, put another quarter wave section of twin lead, and then another half wave quarter section of twin lead, and stack it that way. The Ringo Ranger does that, except instead of having twin lead, they just wrap the wire, around the vertical axis and add another section. And that's your Ringo Ranger. The ZEP, you see the ZEP come up a lot of places.
Yeah, because it's a neat name. ZEP.
They don't call it Zeb.
Yeah, well, they don't call it ZEP,
Oh, they don't?
Well, this one's a Ringo Ranger, this
Yeah.
one's a J pole.
Yeah. But they're technically a ZEP design.
Yeah, it's variations on the ZEP.
All right, so it's basically an in-fed dipole. So it's got a high impedance at the feed point. You feed it with a quarter wave transmission line and some matching network, a ballon or whatever. The extended or the double ZEP is just two of them, so it becomes I guess a balanced dipole that are, and they're 5/8 wavelength, right?
Yeah,
For a ZEP, a true ZEP,
the extended ZEP.
or the extended.
That's why it's not a.
Right.
50, 70 ohm.
So for the single, basically you've got a what, 3/4 wave. Or part, because you've got part of that feed line is acting as part of the antenna, right?
Yeah.
Well, that one, yeah, so it, because like we said, it radiates, right? I mean, but it's a halfway dipole.
But it's also radiating vertically.
But since
And your
you're
other
at the edge,
antenna is horizontal, so you've got a little vertical and some horizontal going on.
Unpredictable pattern.
Well, being a half wave impedes about 2,500 ohms or whatever at the end, so that
Right.
quarter wave
Well,
gives you the impedance.
you saw that
Shorter.
spiky loads and stuff. That's if you're a half wave in the air. Who has an 80 meter antenna that's halfway in the air?
Not me.
You get it, 30 feet, 40 feet off the ground, like most of it's gonna have it. It's gonna, be a little more homogeneous. without
Right.
so many-
A little more omni.
Yeah, a little bit smoother.
Right. Something said for having it lower.
Yeah.
More skyway, more.
Well, if you get low enough, then you got Byron's Nivis
Nivis.
antenna.
Basically a quarter wavelength or less.
I guess it doesn't matter what kind of antenna it is. If you get it low enough, it's
Yeah.
pretty much vertical, right?
Yeah. Any horizontal.
Meter dipole about 12 feet.
There's a name for those.
Right.
Cloud.
So
Too hard.
which of the following describes a ZEP antenna? Guess we could throw away
In the dipole.
This is metallic.
Omnidirectional.
A. Huh?
Yeah, Baker.
Metallic zip cord, but I haven't seen it yet.
Well, let's go with Baker or Bravo. Which of the following describes an extended double zip?
Charlie.
258.
258s in phase.
Charlie.
Okay, G5RV. I'm the proud owner of one. I know nothing else about them other than what it says in the book. And actually, what they show there, it says 51 feet on each side. Mine's 102, so that jive. My feed line, it says, is 30.6 feet. They're saying 34, so it's close. And
This is to 50 ohm coax. Probably that one's to 75.
yeah, because let's see, well, that's loud, so that's what, 450 with a, well, they just say any length of 75, so I don't know. But at some point, you're gonna have to convert that back to 50.
Not necessarily.
Well, true. But I mean, if you wanted a closer,
Delta loop a lot of times will run 75.
okay, so I guess an advantage is it's not a half wavelength long.
Which helps.
Huh?
80 meters, when it's only 102 feet, and you can operate 80.
That's
an
true.
advantage. It is longer than the halfway.
It's not 100
meters. If you-
Not 120
30
something feet, 30 feet, yeah.
Yeah, 30.
Which would make it easier for me to try to figure out how to put it in a 100 by 75-foot lot. Says it was originally designed as a directional single band 20-meter antenna. It tunes, I guess, all of the bands, my understanding, from 80,
Yeah,
Up.
80 up. Mhm.
so it's odds and evens. That's why it's supposedly popular, and they were selling a lot of them.
That's why open wire antennas are nice. So you can get low losses
Right.
with ugly impedances and go everywhere.
Yeah, depending on where I put it, I'll have ladder line almost to my shack entrance.
Yeah, horizontally configured, if you do something like this in like an inverted V.
Yeah,
Yeah, inverted
But-
V is really popular. with that antenna.
but I can only go up about 35 feet, so that didn't kind of quite do it. So I'm gonna have to do something funky with the extra.
Changes your radiation pattern. So
What happens if you do a Z? Do an inverted V and then you have excess going one way and the other excess going the other way.
Go model it with your. It's
You can.
like in the
do
parameters
it.
for that one.
Yeah, well, that actually wouldn't be hard to model.
It would be a little more- it's gonna be unpredictable performance.
You never know. These are
Good.
radiation patterns, supposedly. Um, and showing it at, let's see, that's 80 meters, 3.75. So it's almost omnidirectional. And when we get up to 40, then we're getting more like a dipole. And of a 10 megahertz, you got smaller lobes. I can't tell from here whether or not, well, it's definitely got a narrower beam width. You can see from the red lines. So you got more directional power. When you get up to 20 meters, looks like you're going off at what, 30, 40 degrees on these lobes. They're narrower, but you got 4 of them in 4 different directions, and it's not in the normal direction. Well, although the forward and back is what,
If you
3 dB down, 6 dB down?
If you do the folded dipole or a parallel beetle,
Yeah.
you can actually put a little bit of a twist in the folded dipole and a little bit of a twist in the parallel feed line. And
To reduce the length,
excuse me?
what, to reduce the length or?
No. It's gonna make it even quieter to noise.
Huh?
And it might give it small improvement on the SWR.
Okay. But you can see as you go up in the frequency, you get more of these weird lobes coming out. So, but I guess it's fairly effective from what I understand on all of them. So we'll see. I might even get it in up someday. Which of the following describes a G5 RV antenna?
Yeah, alpha.
Motorcycle gang has arrived. A rhombic antenna.
Transition your window line, what it's called, coax there.
Yeah.
What is that?
Oh, it's just in directly on the connector.
That white thing?
He just used those PVC things and potted them, so it's weatherproof.
Yeah, but that pod isn't any good. I tried it.
Okay, rhombic antenna. It looks like a rhombus. I guess these are really only receiving antennas, right?
As far as
Because you'd
I
lose a
know.
lot of power transmitting because you need a very high power resistor there at the end.
No, but what's one that the military uses as a terminated resistor? It's broadband.
I don't know. But in this case, let's see, is each section a wavelength in this, or is the whole thing a wavelength?
The whole thing is a wavelength, but
It's like a loop, so it's a wavelength around the loop.
mhm.
Okay. And I guess because you do it in the rhombic shape, it gives it some directionality or more than it would be if it was like a square loop.
I never have gotten interested in the rhombic. You know, I read it and said,
Yeah, well, I don't know anybody's done a lot of it before.
Well, they take a lot of space.
Well, yeah, I'm curious why they haven't on the press really, but.
Yeah. Well, I've seen some pictures of very, very large ones that, AT&T and people like that use to do transatlantic type stuff, where they set it over many acres and aim it.
there is tech prepper.
Yeah,
He did no random contacts video using a terminated resistor antenna. And basically you have similar to a dipole, and you have some elements you can, spread apart and put together to give, the beam pattern. And I was actually impressed. I didn't think I would be impressed with the test, it being a terminated resistor antenna, but it did come out with good results.
well,
I think maybe Chameleon or someone like that sells it.
on this one, if you leave the uh, opposite end open, then you get a bidirectional pattern. If you terminate it, it's like 750 ohms or something. Then you just get a unidirectional pattern opposite to the feed point. So it's wherever antenna is pointing. And here I found some pictures of what it looks like terminated and what it looks like unterminated. But you would have a problem transmitting with very much power. You're going to dissipate an awful lot in that terminating resistor, which isn't going to go out as radiated power. So what's the effect of adding a terminating resistor to a rhombic antenna?
Bravo.
Bravo. Okay.
What do you know about the rhombic?
All you need to know about the rhombic. One question, probably not going to get it.